24 lakh students, 55,000 MBBS seats, 2 years of dedication, hard work and sacrifice, and we got one of the biggest scams in the history of Indian medical sciences. "67 students scored 720 out of 720 in NEET 2024. This number is usually 2 to 4. People are calling it the biggest scam that has happened in the medical field of India. The problem started when the news came out that multiple rank 1 holders were from the same examination center, which raised some eyebrows. Following this, there were some conspiracy theories around grace marks being assigned to students with no transparency around how it was being done.
That close to about 70 to 80 marks have been awarded in grace marks randomly to at least 1500 students.
And while everyone's trying their best to understand what happened, what led to such skewed results, let's try to find out who are these people who got a 720. Can we scrape the NEET website to find the results of all 25 lakh participants? How should the website that's putting out the results of an examination be protected? Can we create a publicly available website where if you put your friend's name, you can get back their exact rank as well as their marks from NEET 2024? Let's find out in this video. Alright, you look at a government website, you know it's a government website. In this video, we're going to look at one such website and try to hack it, scrape it, do something fun with it. For those of you who don't know, recently the results for NEET came out. NEET is the biggest examination for medical in India, and there have been some ups and downs. Results are a little skewed. A lot of people got 760 out of 760 or 720 out of 720, which is the highest score. Around 66 people got it. What if you could find out who are these 66 people? Thankfully, the website of any government website, or specifically this one, is, you put in an application number, you put in a date of birth, you click on submit, you get back the result. There are no captchas, there is no rate limiting, there aren't standard things you would expect here, which would give you the power to, extract and scrape a lot of data, as long as you have a lot of machines. If you have a lot of compute, if you have a lot of servers out in the world, you can scrape everyone's data and create a website similar to this. I don't know how many of you saw this, probably not a lot of people here on the channel. But this used to be an annual list that SDS Labs took out. SDS Labs is a small group in IIT Roorkee, where every year they would scrape the JEE result, very similar to how we're scraping the NEET result today, and just put the list out there for everyone to look at. For example, this is JEE 2014 results. If you search for Harkirat here, you will see my rank. What is the benefit of creating a website like this? The benefit of creating a website like this is you can actually verify if someone's rank is right. If you're ever scared of asking your co-participant roommate what their rank was, or if you're wondering what they're from a category, this was the website people looked at. Got super viral back in the day, and I think some senior of ours back in 12-13 put ads on it and made like $500, something like that. So only possible in a government website. That's what we'll be doing today. This is the NTA website, no captchas. I've tried this already. It's currently running a bunch of workers of mine in production. If you want to see, we have a total of, wait for it, 8,600 ranks already scraped. Now NEET has 25 lakh ranks, so there's a lot for our workers to do. How did I write these workers? How can you scrape 25 lakh results from a website like this? How long will it take? How much compute would we need? Is all that we'll be discussing in this video. With that, let's get right into it, guys. Let's look at some brief context before we proceed. Alright, so the starting point of today's application is going to be this NTA website, where you can come, put the right credentials over here. For example, for this application number, which I found through a friend, this is the right date of birth. If I click on submit, it'll take some time right now. The website is slow. I don't know who's to blame for that. But after a while, you'll see their actual result, including the rank that they got and the total marks that they got. The goal is to create a website where you can get these results for everyone, all the 25 lakh participants. We'll also try from time to time to scrape other endpoints, see are there other endpoints that we can exploit / understand. We won't be exploiting anything, at least on YouTube, but we'll try to see, is there an endpoint that you can hit to get back how many grace marks someone got? Can you get someone's OMR sheet from an endpoint? These are things we will try. Most probably we will not succeed. If we do succeed, it'll probably not be shared on the channel. Core learnings from what we'll be doing today include number one, how can you scrape a website? This is just one website that you can scrape and get back a user's results. Another common use case that you might have heard of is the US visa appointment line. If you've ever tried to apply for a US visa, business visa, let's say, you'll get a date in 2025 unless you are constantly checking on this website ke, hey, did someone revoke their appointment by any chance? A lot of people have written Chrome extensions that are paid that simply do this, that simply keep checking okay, is there an extra slot available in the US visa list over the next, let's say, month or two, and then people just pay for this. My friend paid like 50,000 rupees to get a slot. So these are standard businesses that are built out of scraping websites. You're only able to build these scraper websites because the logic on whatever you're scraping is not very solid, and usually that happens in government websites. Similar is the case for the US appointment website. How to handle rate limits? Ideally, when you're building a system like this, you should do something called rate limiting. You should do a bunch of other things. We'll understand what that is and why we were able to do this. And if this website did implement rate limiting correctly, then we wouldn't have been able to do it. How to start thousands of machines? Right now, as you saw, I could only scrape like 8,000 people in the last 2 hours. That pretty much tells you, okay, my machine isn't enough to scrape all 25 lakh results. It'll take me years. And hence, I need to start a lot of workers somewhere around the world. How can you start thousands of machines that do a specific task and then downscale them? How much compute will I have to spend for this? How much money do I need to spend? If let's say I do start 1,000 machines, how long do they need to run? We'll do some basic paper math on this after we have been able to reach, let's say, 50,000 users. We'll try to extrapolate that to 25 lakh people. Core things to do when you're building a system like this. You should have captchas at the very least. Here, they should have a captcha that you need to click on, and only then can you click on the submit button. Else, scraping it becomes easier and easier. It's not like you can't scrape it if you have a captcha here, but it gets slightly trickier. Rate limiting, if they had basic rate limits set up, I wouldn't have been able to, send them so many requests. They should be blocking me beyond a certain point, by which I mean they should be blocking the IP of the current place that I'm in. DDoS protection, if they do rate limit my IP, I will try to start a bunch of machines all over the world and send them requests from there. This is called distributed denial of service. Even though I'm not trying to do a denial of service attack, I'm still trying to hit the endpoint a little too much. How can they protect that? How can you protect that if you're trying to build a website like this? And then lastly, OTP sent to users mobile to verify them. Ideally, if you want to protect a website like this, when a user comes with an application number and clicks on submit, they should receive an OTP on their registered phone number. They should put the OTP here and then you're sorted. You don't have to do anything else. That's as secure as it gets. So these are the things that should ideally do if you're trying to build a system like this. This is probably what the government should do as well. I'm sure there is no engineer in NTA that's writing this. It's been outsourced to an agency that's not been doing great for the past few years, because this has been happening for years now. Code along, simple one. I'll take you through the problem statement. We'll try to, from first principles, understand, this is how you capture the request. This is how you convert it into Node.js code. And this is how you write a for loop that just, hits it infinitely and for, a really long time. Core deep dive advance. Now, this is a code along. You and I will be coding it along, slowly and slowly. This is code that I've already written. I've written slightly advanced code so it can scale. There are two things. Number one, it can scale, which means I can start multiple instances, all of which are scraping the results so that I have multiple nodes running all over the world. For example, right now, I'm running, I think 10 pods in like 5 Kubernetes clusters, so like 50 machines that are trying to constantly get the result. How can you write code like this that you can, quickly deploy to various regions? So, requests are coming from various places. It feels like there is not a single person who's trying to hack or whatever, scrape. And more specifically, I want to talk about how this can be decentralized a bit. Specifically, I want to talk about decentralized physical infrastructure networks. If you've heard of them, deep in, very common in Web3 today. TLDR of it is, how can I tell a lot of my friends and family to run this on their machines so that I don't have to pay for a lot of compute on a cloud provider like AWS. How can you build the system in that way? That's what we'll understand here. The reason I wrote this advanced code was because I wanted to just share this in the cohort so that people can just run this on their machines, whoever has, empty compute at the moment. And, we would have been able to scrape the whole thing fairly easily and, cheaply. I wouldn't have had to start so many machines. Tech stack is Node.js for the simple version. That's all you need to know. Maybe a little bit of client server architecture, what are requests, what are responses. Advanced version, that's a brief of what you need to know: Prisma, Postgres, Docker, Express, maybe a little bit of Kubernetes. And then lastly, prerequisites. Basic Node.js knowledge is good enough. Client server model, if you know, great. With that context, let's get right into it, guys. Let's understand, when I saw this page for the first time yesterday, what was my thinking from first principles? How did I arrive at, this is the final script that I can use to start to scrape everyone's results. All right, let's try to build this from first principles. Our goal is, we want to brute force a bunch of requests to the backend of this system. We want to send thousands of requests. If this is the NTA server, we eventually want to send thousands of requests over here. We need to figure out what endpoint do we need to send the request on. Does it look something like this? nta.neet.result.com, and what body do I need to send along? And then I can just brute force on this body. I can first send application number, some random number, and then date of birth, some random date in the year 2007. I'll send this. If this doesn't work, I'll change the date to be 02 and send this. If this doesn't work, I'll change the date to be 03, so on and so forth. I'm going to brute force over all the dates that exist from 2003 to 2007. That's usually the range where, someone might have been born if they're giving NEET this year. And the application number, thankfully I have this one to start with. I'll just keep iterating up from here: 516, 517, 518, so on and so forth. The question is, what does this request look like? What is the URL at which I need to send a request? What is the body? And the answer is, thankfully, when you're opening this website, just open Chrome Developer Tools first. So if you're opening the website, first click on Inspect, right click, Inspect, open the network tab, and then open the NTA website. If I open the NTA website with the network tab open, I can put in the right credentials, the ones that I know. For example, this is the application ID and the date of birth is 8/03/2007. Now, before I click on the submit button, I'm going to get rid of all the existing requests that have gone out until now, and then click on the submit button. When I do see this page. And if I open the very first request that I had sent out, you will see in this very first request, I had given out a CSRF token. Ignore what this is. The user's application number, date of birth, month of birth, and year of birth. So this is the request I now need to brute force. This request that's going out to neat.ntonline.in/frontend/web/scorecard/index, which is a post request, is sending this payload. And if you're sending the right details, you're getting back some HTML that looks like this, which has roll number over here and, amongst other things, has the user's physics score, chemistry score, biology score, so on and so forth. So whenever you're scraping these websites, let's say if you were on the US visa website and trying to find the endpoint there, just open the network tab, press the right button, and you'll see the request. This might feel weird to a few. How is a post request sending back HTML? That usually doesn't happen. That happens when you use PHP. That's my guess of what these guys have at their backend. So over there you'll see the client send out post requests, yet the server return HTML in response. We now need to somehow send these requests from a lot of machines with a bunch of these parameters brute forced. What does brute forcing mean? Keep changing them from 8/03/2007. If this doesn't work, then 8/04/2007, so on and so forth. The easiest way to do this is you right click over here and copy this request as curl. I repeat, right click, copy as curl. This will give you the request in a format that's called curl. Curl is how you can send requests from your terminal. If I open this terminal and paste the request that I got, what does it say? It says send a request on this endpoint with these headers, and this is the data that I am sending. That includes the CSRF token, which ignore what that is, application number, month, year, and day for the user's scorecard model, which I'm assuming is their backend database model. If I press enter, it returns me a bunch of HTML. This HTML, when rendered, looks something like this. Question is, how do I convert this into a Node.js script or a Rust script or a Golang script? There are a few ways. You can always just look at the curl and try to recreate it. This was our curl request. The easiest way to do this is go to Postman, which lets you send requests to a backend. Click on import here on the top left and paste your curl request over here. So if I copy the curl and paste it here, it'll create a Postman request object for me here. If I send this request, you will see I get back response, which is HTML response. If I click on the preview tab over here, I'm actually able to see the user's scorecard as well. Now I just need to change these in the body from 08 to 09 in case 08 is the right result here for this specific application ID. But if we change the application ID, if I make this 0517, then for this user I need to brute force all the dates from 1st January 2004 to 31st December 2007. How can we do that? How can we convert this request into some basic Node.js code on top of which I can create a for loop that iterates over all of these dates, months, and years? The answer is, thankfully, again, Postman gives you a code section at the top right. You click on the code section. It lets you export the request in any language of your choice. For us, we are going to use Node.js, but feel free to choose a different language. If you're writing this in Rust, which is a good idea here, I can share later why, but you probably want to write this in a language that's faster than JavaScript, because we'll be running this on a lot of machines. Every performance bit that you can save here is going to save you a lot of money when you scrape this at scale. Let's copy over this Node.js code. Let's see what it says. It says import the Axios library, import another library called QS, which stands for query string, and then encrypt, put all the data in this query string format. That includes the day, the month, the year, as well as the application number. Totally ignore this CSRF token. I don't know why they have it. I don't see any reason to have a CSRF token on a post request that does nothing, changes nothing on the backend, but sure. You do need this though. If you don't send this, it will just block your request. You create the config, which has the URL where you'll be sending the request, and a bunch of headers. Some of these you probably can skip, but it's fine. And then lastly, the data object that we had created above, we call axios.request. Axios is a library that lets you send HTTP requests from a Node.js process, and then whatever response we get back, we log. Eventually on this response, we have to do a bunch of things. We need to parse out the user's marks and things like these. But before we get there, let's copy over this starter code into an empty Node.js project. How do you create an empty Node.js project? Number one, you create an empty folder somewhere in your machine. I'm going to create it here in the projects folder and call it neat-scraper-live. If I go to neat-scraper-live, I'm going to now open this in Visual Studio Code, which is an IDE. Feel free to open it in whatever IDE you prefer. Then I'm going to initialize an empty TypeScript project in here. You can also use JavaScript. This will be a very small script, so it doesn't matter. You don't need extremely fancy TypeScript in this specific project. npm init-y to initialize a package.json, npx tsc-init to initialize a tsconfig.json, and lastly an index.ts file where we'll be writing all of our code. If you remember, there was a library that we were using in Postman. If I take you back to Postman, I selected Node.js Axios over here. This Axios is an external library that makes your life a little bit easier when you're trying to send requests. You can totally select Node.js native over here, and then you won't have any external dependencies. But if you use Axios, your life is a little bit easier or more easy to write when you're writing code. So we're just going to go with this. If you are using external libraries, you have to bring them into your code base. The way to do that is npm install Axios, and then QS is the other library that we have to bring into our code base. So what is the code that I'm running? Npm install Axios QS. This will bring this and this library into our code base. And these are the two libraries that we're using over here. Rest of it, I can copy the whole code. I can paste it here. It does give me a bunch of errors because this is JavaScript code. Let me convert this to TypeScript. I also have to install at types/qs so that I can get the types for this QS library. If I run this, this red squiggly over here goes away. The rest of the code looks fine to me. I don't see anything wrong in the rest of the code. The next thing you have to do is install TypeScript, npm install TypeScript. And lastly, in package.json, add two scripts, one called build that would build your TypeScript file, convert it into a JavaScript file, and then start that would start your index.js file, or run node index.js. This would create the index.js file, this would run it. You can also add a dev script over here that first does npm run build and then does npm run start. That means it will first create the JavaScript file, then it will run it. If I run npm run dev over here, it first creates this index.js file, then runs it, and you can see I see the HTML response in my terminal over here. The HTML response that was returned to me here in this browser and even here in Postman, I can now see in my Node.js process. I have been able to write a simple Node.js file, a TypeScript file, where I'm able to send requests to a specific backend with some parameters which are right. Now I need to write all the brute forcing logic. I need to send a bunch of requests for, let's say, another application ID. This one though I have the result for. I know the marks, I can get the marks, whatever. I need to now iterate over all date of births for a new one, let's say 718 over here, and find the right date of birth for that user. For that, number one, let's put all of this code into a function so that we can call that function again and again. I will create a function called solve, let's say, which will take in the application number as an input, the day as the input, the month as the input, and the year as the input. And here I will put all of the logic to send out the request. I will also make these parameters configurable now. Okay, the day actually comes from this day argument 08. Month comes from this month argument 03, and year comes from this year argument. Application number comes from this application number argument. Everything else can remain the same. Let me convert this into an async function, and let me send this request in a different format. Let me do await const response equal to await Axios.request, and then do a console.log response.data. This is how I've now converted the code into a smaller function that I can just call with various arguments. The very first argument I'll be calling it with would be the right ones, basically this application number, and then 08 03, 2007. If I run this, it should do the exact same thing. I've just encapsulated all the logic into a function. That's the only thing I've changed. And then I've just called the function over here. I, of course, eventually need to put this inside a for loop, and we're sorted. Let's see if I can send this request and if it still works. npm run dev. Still seems to work. I do get back sub HTML. This looks like the wrong HTML. I don't know why that is, but we'll see this eventually. Application number, day, month, year. Application number, day, month, year. That looks right. Now, comes one extra thing that we have to learn, which is, okay, usually when you're sending requests to a backend server, the data that you get back is in JSON. What is JSON? JavaScript object notation. If I open any random website and refresh, you will see the requests that are going out, specifically the backend requests, if there are any. This website doesn't seem to have any. But even this one, this specific manifest.web manifest file, returns you a JavaScript object. It has keys and values. Name is Excelidraw, short name is Excelidraw, so on and so forth. It doesn't return you HTML. This is good. If you have JavaScript object notation that comes back, you can simply do something like response.data.marks or response.data.rank and get the actual rank of the user. If this specific endpoint returned you JSON data, then we would have been able to parse it like this. But since it returns us HTML, we need to parse the HTML a little better. I repeat, we need to convert the HTML that I get and get out the user's rank from it and maybe the user's marks from it wherever they exist over here. I don't know where they exist. This user got 355, 55. Oh, that's their marks. So what's their rank? This is their rank. Makes sense. So we need to extract out this and this so that we can eventually store it in a database. That database is what will serve our final website that looks something like, this. That website will get all of this data, the results of NEET from that database. So we need to now send a request or store all of this data in a database. Before that, we need to parse out this HTML file. Let's see how we can do that next. All right. Given that you have some HTML and you need to parse out data from it, for example, parse out this field over here, which is the total marks that the user got, or this field over here, which is their AIR. There are a few libraries that let you do it. You can write logic yourself to go through the whole HTML string, or here are two libraries in Node.js that make your life slightly easier. If you want to parse out the whole HTML into a tree and then, find a place where total marks obtained exists and then find the next table column right next to it and just extract out the value. Two such libraries in Node.js are Cheerio as well as Node HTML parser. Node HTML parser, as the name suggests, lets you parse HTML. That is exactly what we want. We want to convert a given HTML that looks like this into some sort of an object in JavaScript so that we can find where does this specific text exist and then find the key right next to it. Node HTML parser is one library that lets you do it. If you do this, use the library, parse it out, get the root of your HTML tree / DOM tree, and then just iterate over it, find the place where this string exists and then find the column right next to it. That's one way to do it. The other library is Cheerio. This will make our life slightly easier. So this is the one that we're going with. Either way, both of them work. If you're using Python, Python has this library called Beautiful Soup, I think, that lets you do the same thing. It lets you parse HTML and get back certain text, columns, everything you have access to an HTML from it. For this library, again, you can load some HTML and then do some operations on top of it, find certain strings. In our case, what do we want? We want this specific column, wherever it exists, wherever is this HTML tag, I want to find the one right next to it. And I want the internal value of it, right? How can you do that? Let's first look at the structure of this page. If I click on more tools / developer tools, it will open this bottom tab for me. If I go to the network tab, you will see, sorry, not the network tab, the elements tab. I will search for, let's say, total marks obtained. Total marks obtained out of 720 appears over here. It is inside a strong tag, which is inside a TD tag. What do I want? We want here whatever is the next TD tag, right? I want the internal contents of it, maybe trimmed out. I don't want this extra space here. But other than that, I want, wherever this string exists, I want the TD tag right next to it and the internal text of it. How can you use the Cheerio library to get exactly that? Number one, if you go back to the code, you'll see I've written this parse HTML function. Ignore this completely for now. First, install the Cheerio library on your side by running npm install Cheerio. Then go to the top and import Cheerio in your Node.js codebase. And lastly, let's look at this parse HTML function that I've written. Cheerio.load returns you a specific object that you can, query on top of. Why is it named dollar over here, Harkirat? Don't ask, because this was written as jQuery back in the day. If you know jQuery by now, you probably know what this dollar is. If not, that's fine. You can name this whatever you want. You can name this, Cheerio loaded data as well. Dollar is just, standard practice for this specific library. Then you say, I want the application number, which exists in the TD, the table, whatever this tag is, the TD tag, which contains application number written. The next TD tag of it, I want the text of it, I want it to be trimmed out. I repeat, where can I find the application number? If I put this on the right and put this on the left, the application number can be found in the table tag that contains application number written. Let's see where that is. That's right here. Next TD. I want the next TD tag, which is this one right here. I want the internal text of it, which is, this text right here. I want it trimmed out in case there were some extra spaces here. I want them removed. That is how we get the application number for this specific user. Do we need to get the application number? No, we already have access to it, but okay. That's the first thing we parse, which is, parsing out this application number right here. What would be the second thing? Find the table tag that contains candidate's name written. So let me copy this. Let me paste this here. I see candidate's name is inside again a TD tag. I want the next TD tag and the contents of it. So the same thing is written here. .next, .text, .trim. The table tag that has candidate's number written. Find the next table tag, or the next tag in this case, which is going to be this one right here, and find the internal contents of it. Oh, CDG, I just lost it, but you get the idea. That's how you get the candidate's name, and similarly you get the all India rank and the total marks for the user. Marks are slightly different. There are two sort of columns here that say total marks obtained out of 720. So you have to do one extra thing. Find the table tag which has total marks obtained out of 720 written, but the first one, find the first one amongst these two, and then find the next TD tag, which will be this one right here. Find the internal text, trim it out, so on and so forth. That is how you can parse out the total marks for the user, the all India rank of the user, the roll number, the application number of the user, as well as the name of the user, which exists somewhere here. I got rid of it when the tab was open, but you can get it here. You can also extract things like date of, you already have date of birth, but mother's name, father's name. As you can see, it's fairly insecure. This should be protected really well. There's a lot of data of a lot of NEET aspirants who are going to be future leaders in 10 years. All of their data is just dumped on a website that anyone can brute force on. Let's see if this works. If I go back here, you will see now, after I send the request and get back the response, I try to parse the HTML. Get the HTML, convert this into string, the response.data that I get back, I convert that into a string. I send that to the parse HTML function. And if I get back some parse data from here, I log the marks and the all India rank of the user. Let's say there is a good chance I don't get back any data because, this was the wrong credentials. I am getting this very pretty page right now because I put in the right credentials. If I put in the wrong credentials, I will not get all of these fields, in which case you can just return, null. I could not find the specific user's details. If I try to run this code, npm run dev, you will see it logs the right thing. It logs the rank of the user, marks of the user which were logged here, and the rank of the user which was logged over here. This sounds pretty cool, right? Okay, now if I send the wrong credentials, if I send the wrong date of birth for the user, then it will tell me, hey, sorry, it doesn't exist. It won't log anything. It will say application is NA, candidate name is NA. And then if I do send in the right credentials, then it just, tells me the application number. Can you now write logic that brute forces all the what do you call it, date of births that exist? What do I have to do? I want to iterate over all years from 2004 to 2007, that keep hitting solve one by one a few times, and then whichever one hits, then I know I got the answer for this user. Let's try to find the answer for a user who has a different roll number, let's say 17. Let's write the code to iterate over all the date of births now, and when the first date of birth hits is when you found the answer for that specific roll number. Let's change the roll number to be 17, and let's write the code. What do you think the code should be? Let me write a function called main, async function main, inside which I have to now call solve, but I have to call solve inside a for loop. I will say for year equal to 2004, or let's start from 2007 and make our way down, because most people, I would assume, lie towards the year 2007. So for year equal to 2007, year is greater than equal to 2004, year minus minus. For month equal to, the question is, it's one base most probably. 1 month is less than equal to 12 month plus plus, and then lastly for day, that looks right. Need to put a let here, and then let day equal to 1, day less than equal to 31, day plus plus, const data equal to await solve. Let's take the roll number as an input here, roll number string, and then this roll number is what we'll be calling it for. Okay, trying to solve it for this day, this month, and this year. If data exists, so firstly I need to make sure the solve function indeed returns us something. We're returning, what are we returning in the solve function? Nothing right now. We should simply return parsed data. This would either be null if this specific request fails, or it would be an object which has 4 fields. So I can simply get this parsed data and return it from here. I have a main function that looks rightish. Let me call the main function async function main. There we go. If data, then we can log data and we can just exit the process.exit. Let me remove all the other logs from here. All right, that looks right. I have written a for loop which iterates over all the dates one by one, and whenever you find the data, it logs the data and exits. Maybe I should also log processing the data for this roll number for this specific date. Now let's try to find it for a specific roll number, a random roll number, or we can find it for our roll number as well that we already know the answer for, but we'll be able to compare the answer. Well, either is fine. I can do it for the one that we already know or for a different one. Now this is very slow, so you don't try it on your side. This will take 10 minutes to do. We'll see how to speed this up. But right now, since we're iterating date over date, we're literally going over 1500 dates one by one. It will send the first request. If it doesn't happen, then it will send the second request. If it doesn't happen, then it will send the third request. Since we're sequentially sending requests, this will be really slow. Just for testing purposes, let's see it. And then, once we do see the results, then we'll move on to optimizing it, making it a little bit faster. So as you can see, it did not work for 1st January, did not work for 2nd January 2007, did not work for 3rd January 2007, 4th, 5th, so on and so forth. I'll let this run, and when this succeeds, the video will restart. We'll make this a little bit faster. All right, as you can see, after a bunch of iterations, we were able to reach the right date of birth for this specific application ID. If I try the same application ID in Postman now, I'll probably be able to see the result. Let's do that really quickly. It's 2007-4-28. So if I go to Postman, 2007-28-04, I got back the result for this user, and this specific user has made, whatever, 91 marks in the NEET examination. All right. This is cool, but this will take a really long time. Why? Because all of these requests are going out sequentially. As you can see, I first sent the request for 1st Jan 2007, waited for it to respond. If I did not get the right response, if I got the right response, I exited the process. But if not, then I moved on to the next result. Then I tried it for this guy. Did not happen, tried for this guy, so on and so forth. This will be really slow. What we have to do is send batch requests. If this is the NTA server, I don't want to hit a request and then wait for it to respond and then send the next request. I want to send it, let's say, all the requests for a month. I want to tell it, hey, can you give me the results for 01/01/2007? And then another request I want to bombard immediately for, let's say, 01/02/2007. And then another request for 03/01/2007, so on and so forth. I want to send, let's say, 31 requests together, and then wait for all 31 to come back and then check did any one of them succeed. If they did, great. If not, then send the next 31. I want to send the requests. If this is my Node.js process and this is their backend server, I want to send, let's say, 30 requests together, wait for them to respond, then send the next 30 requests. Harkirat, why not send 200 requests? Why not send 20,000 requests? Why not send all the requests together? The answer is there are so many, socket connections your server can handle or your process machine can handle here. You can't just, send infinite messages to the other side. They will start to get queued at some point. So it's just a good idea to have logic in your Node.js code only. I'm going to only send 30 a second or 50 a second. You can arrive at an optimal number here based on, if I send 50, how much time do they take? If I send 25, how much time do they take? इस हिसाब से you can configure whatever is leading to the least amount of time taken when it comes to requests per second is the optimum number you can choose. But when writing the logic, it's just easier to send all the requests for a month, and hence I'm going to change the code to now not send requests daily. I repeat, I'm not going to send one request for day one and then the next day and then the next day. I'm going to send 31 requests for the month of January. If it succeeds, if any of them succeeds, great. If not, I'll send all the requests for the month of February, so on and so forth. Now here is where, a little knowledge on promises, async functions would be good. I will still try to explain what I'm doing, but it's bound to be confusing if this is the first time you're dealing with the promises API. Let me share how exactly you do this. What we're doing right now is, for every iteration, if there is these many years, these many months, and these many days, I am waiting for the request to succeed and then proceeding to the next iteration. What I want is, 31 requests, please go together. So what I can do is, I can say here const data promise equal to solve. I repeat, not await solve. I am not awaiting for the function to get called. I am calling the function and storing whatever it returns in this variable called data promise. Now the question is, why did you name it data promise? Let's hover over this solve function. What does it say? It returns a promise. Harkirat, no, it does not return a promise. The solve function, if you look at it, what does the solve function return? It returns parsed data. What does parsed data return? The parse HTML function. It either returns null or an object with these 4 keys. Where did this guy return a promise? And the answer is, since this is an asynchronous function, it actually does not return null or an object. It actually returns a promise of either null or an object. Now, Harkirat, what is a promise? It's just syntactic sugar. What is syntactic sugar, Harkirat? It's just an easier representation that this function is not immediately returning anything. The solve function is sending a request to a server, right? This request can take 1 second. This can take 10 seconds also if the NTA server is really slow. And hence this isn't immediately returning you null. It is returning you a promise कि I will eventually return you either null or an object which has a specific shape. That is what a promise means. Now, if you await it over here, when you're calling it, when you await it, then you're saying I will wait for the promise to get resolved, or I will wait for the promise to finally return the value. And then the thing that gets stored here is either the object or the null value. But if I don't wait on it, I'm like, yeah, I'm going to call the function. The promise will eventually solve. I am going to proceed on to the next iteration. I want to keep running all of these iterations one by one. Then this does not return. Then the thing that's stored on the left here is a promise. I repeat, let's remove this line of code. If I simply call solve, then the return type here is promise. But if I call await of solve, then the return type here is the actual data. So what do we want? We don't want to await. We don't want to send sequential data. I don't want to wait for these 31 requests. I want all of them to go together. And hence, I will simply say const data promise equal to solve. And over here, I will wait for all 31 requests. I want to send a bunch of requests. I want to send these 31 requests together. After I'm done for the month of January, I want to then wait for all of them to happen. Then I want to move to the month of February. I want to call 31 requests together. And then I want to wait for the next 31 requests. So the await logic that was here, I was awaiting solve over here, now will get moved here. Okay. Await for all of these promises to get resolved. What is this data promises function? It will have all the 31 promises for that iteration. This is the final code that you have to write, which will now send 31 requests together. What is happening? KR for every year, for every month. Let's say we are in 2007, month of January. Now we are saying KR data promises is an array. And for 31 days, I'm going to push to this specific array. I'm going to push 31 values over here. And then I'm going to wait for all 31 of these promises. I'm going to wait for all the 31 requests to get processed. And then I will move on to February. And then I will again send 31 requests together. Harkirat, how are 31 requests going together? Because I have not written await over here. I'm not saying for day one, wait for the first request to go out. I'm saying for day one, send out the first request, forget about it. For day two, send out the next request, forget about it. So on and so forth. 31 times I'm sending responses or sending requests, and then I'm waiting for all 31 of them. That is how you send batch requests. Why is this good? Because you're now parallelizing a bit. You are still not sending 1,000 requests together. That's a very bad idea. You're finding some optimal number, which in our case is 31. Okay, let's send 31 requests. The other side will respond back in a few seconds. And then let's see. Here we still have to see. Okay, did any one of them succeed? And if they did succeed, we will stop the responses right there. We'll stop the iterations right there. So what else extra logic do I have to add here? Here, whatever data was returned over here, const resolved data equal to await all the promises. This resolved data will be an array of the return values of those 31 requests that you have sent. And here I can be like, for every resolved data for each, for every request that we had sent out, did any one of them get back any data? And if we did get back data for any one of them, I log it and exit out of the process. That way, I've sped up my process a bit. I'm sending 31 requests together. I'm checking all 31 of them together. And then when all 31 of them succeed, I'm then moving on to the next iteration in case none of them return the response. In case any one of them return the response, then I'm just logging and exiting the process right there. Let's try to run this code now. Maybe let me write some code over here. Sending requests for month of the year. Now if I try to run this, It's happening a little too. Okay, let me remove this log. Sending requests for month 1 of year 2007. 31 requests have been sent. We are waiting on them. Once this succeeds is when we'll move to the second iteration. Now it's sending requests for month 2 of 2007. 31 requests have been sent. Then the month 3, no response has been found yet. It will keep on happening, but as you can see, much faster than what we were doing before. When we were sending individual requests, each request was taking 2-3 seconds. Now we are sending 31 requests, which are taking 10 seconds, but on a per request basis, request per seconds is really high. And then finally in the 4th month, we were able to find a response. Can we now just put another for loop and start iterating over all the application numbers and we're good to go? Let's see if we can find another one. Let me change this to 1.8 and then rerun npm run dev. Now it will try to find the date of birth, the right date of birth for this user. Let's see how long this takes. There we go. Took like a minute and a half because this specific user was born in 2005. I'm sure it's an easy ride from here. I just have to put a for loop over here for let I equal to 0, I less than, or whatever. I equal to, let's choose a starter application number, maybe something like, replace these last 6 digits with 00000, and then ending number as replace the last 6 digits with 999999. Iterate over all of them, and then solve every application one by one. Function solve something like this. Then I can just, let's call it all applications, and then let's just call it something like this, right? I can start to iterate over all the relevant application numbers for NEET. Now, I don't know if each one of them is relevant. I would assume so. The script that's currently running in production, sort of every application number that we pick up works. So, anything in this range, I think is fine. These are 1 lakh correct application numbers is what I feel. I don't know, could be wrong. Let's try to run this for a few of them. It might actually be wrong. This seems like, I don't think no one would have such a lucky 0000000 kind of a number. Let's change the starter to be, some 3, 5, something like this. And let's see, do we start to get the right values for these application numbers? Let's just run this, not infinitely, for like 5 minutes and see where we reach. You'll see an exception is thrown. The NEET server goes down from time to time. So what you have to do is make sure whenever you're sending the Axios request, which is this guy right here, put this inside a try catch. And if there is an error, ideally you should retry, but for now, we'll simply return null from here. So in case the NTA server is ever down, we just ignore that specific date request that we're sending out. This isn't great. We should add some retry logic. If the NTA server is down, we should retry in 5 seconds. Let's try that one more time. There we go. It's sending requests. Let's wait for a few minutes. Let's see where we reach. Shoot. I was exiting the process. I shouldn't do that because I want an infinite loop to be running. As you can see, very quickly Divya came, but at the same time, we need to move on to the next iteration, and hence this needs to be not process.exit, but something like let solved equal to false. And here I should not do process.exit1. I should do solved equal to true. And in every iteration, I should check, every month iteration, I should check if solved, then break out of it. Maybe in every year iteration as well, I should check. If this is already solved, then I don't need this specific iteration to run. I can just break out of it. Again, what did I do? Rather than exiting the process over here, I'm simply setting solved to true, which will in the next iteration break this out, which in the next iteration will break this out, and the main function will stop to be called, and then it will get called for the next iteration so that the process perpetually runs. Let's try that one more time. Divya happened a little quickly, so we can just, do it right now. Let's wait for another month. There we go. So we got the result for Divya, and then we moved on to the next roll number, whatever that is. Now let it run for like 10 minutes. Let's meet back in 10 minutes and see how many were we able to get. All right, I let it run for a while, and as you can see, it's doing its thing. It got the result for the first user, then after some iterations, got the result for the second user. This user was born in 2005, hence took a longer time. This user was born in 2006, 2004, so on and so forth. We've been getting results for a while now. Looks like we're, onto something here. It's just that we have too many records. We have 25 lakh people who have given this examination. One machine, unfortunately, isn't enough. Harkirat just start 10 different instances. Another terminal, open another terminal, and then just run npm run start here. I could do that, but at some point, there are so many connections my machine can support. I can get IP rate limited, even though I won't. They don't have that logic. But you get the idea. A single machine isn't enough to handle all of this. I also have to make sure I don't keep starting all over from this specific number. I want to mark certain users as done, and then move on to the next roll number. I need a better way to run this application anywhere, be it a Mac machine, a Windows machine, a Linux machine, AWS machine, a GCP machine. And hence the next step is, number one, changing the architecture completely. The architecture I've already written. Number two, understanding why that architecture is better, especially if you want to distribute this worker logic everywhere. This logic of it running and finding the date of birth for an application number is very similar to Bitcoin mining, right? Very weird example I took, but bear with me for a second. How do Bitcoin miners make money? They have a lot of machines running, and all of these machines are solving a specific problem. They're calculating the hash on that, or solving the specific puzzle for that block. The one that does it gets incentivized with some, let's say, 4 Bitcoin. That's how Bitcoin mining works. And similarly, what do we want? We want, one machine isn't enough to scrape 25 lakh people. We want a lot of people in the world to try and solve these problems, or solve the date of birth for a specific application number in all of these machines. And when they do, they should let a single central server know, okay, hey, this is the date of birth for this specific application number, and then they should get incentivized some money, whatever. So first step here is build an architecture that supports this. How can you have workers solve? How can you make sure it's safe? How do you give them some code but not all of your code that they can run on their machine? What is this even called? And for those of you who've already heard of it or belong to the crypto world, this is called decentralized physical infrastructure networks. I can totally do this on a cloud provider as well. In fact, I will be starting a cloud provider very soon. I'll start a cluster of machines that I'll be running this. But at the same time, the thing that I want to teach through the video is around crypto incentivization a little bit. Okay, what if I know this is going to need like a lot of machines? What if I could just give it out in the world, and whoever solves the problem gets some crypto money, Bitcoin, whatever. It's like the better way to solve this, right? Or like another way to solve this. I can also start 100 machines on AWS, and that would solve the same problem. I just know it'll be cheaper if I do it this way, because AWS has a markup. Users, you can decide what to pay them. With that context, we'll move on to the next section. The last section for today's video is going to be, go back to the slides here. The last section is going to be a deep dive of the architecture as well as the code that I had written yesterday, which you can use to distribute this solve logic to a bunch of users, and they can solve the problem for you. A single machine you don't have to run it on, you can run it on thousands of machines. With that, let's get into the next section. All right, here is an architecture of how you can build this such that you have a central system where you're storing the applications that have been solved, that might be picked up by workers but haven't been solved, and the ones that are not solved right now. This data is stored in the database, and this database is connected to an orchestrator service. What does orchestrator stand for? It stands for, I'm going to orchestrate other workers. Anyone can start a worker. Whenever they do, I will tell them what application to solve. It's similar to a leader in a Bitcoin network or Ethereum network, where you submit your transactions. You ask and tell this server, okay, what application should I solve? And whenever you're able to solve it, you can tell the server, okay, I've solved this application, this is their date of birth. The orchestrator will store it in the database. That's the first service we're building. And the second service is simply a worker. This worker I can start on my Mac machine. I can start in an AWS server. I can start on a Google Cloud server. Doesn't matter. You can start it at your home as well. This worker, number one, hits the orchestrator and asks it, hey, do you have a problem for me to solve? Do you have an application number that you can give me? The orchestrator returns back an application, and then the worker does its thing, solves the problem whenever it is able to. It just posts back its result to the orchestrator. The orchestrator stores it in the database. That's a brief of how we've built the system. Database access is restricted to the orchestrator so that workers don't have access to your database. They can't really update data, delete data, read data. They can simply ask for the next application to solve and tell I've solved this specific application. This is a brief of the architecture. The database looks something like this. We only have two tables. One table called application number. As you can see, this has like 10 lakh rows. It basically has all the application numbers that we need to solve for. Now, some of them have been picked up, which is why pickup time is something. It means a worker has started to work on this problem. And some of them, if you keep going down, you'll find have pickup time set to null, which means they are yet to be picked up by one of these workers that will solve the problem. That's the application number database. We only have 10 lakh rows over here. We should ideally fill this up to 25 lakh rows because 25 lakh people have given the NEET examination. There are 25 relevant application numbers to solve for. Secondly, there's the results table, which currently has 11,000 entries, which means we've been able to solve for around 11,000 people. If I go to the results section over here, you'll find the results for a bunch of users for this application number. This is their date of birth, and this is their all India rank, and marks was something I added eventually, which is why some of them have marks set to null. But all India rank is basically this for a bunch of users. Believe it or not, we've been able to scrape one user who has got 720 out of 720, which means has AIR of 1. I'm sure I can find that row somewhere here, but you get the idea. That's a brief of the database. Fairly simple database, fairly simple applications. We'll be going through their code very soon, but both the services, be it the orchestrator or the worker, are fairly simple. They're all Dockerized. So if you want to run it today on your machine, you just have to run a single Docker command, docker run 100x dev/neet, I think, or docker run 100x dev/neet:/mac, and a worker will start on your machine. If you have a free machine at your house and you start it there, you can start to solve this problem for us. And if this was a true application in the crypto world, you would get incentivized for it. If you solve 20 application numbers, you would get some pennies, dollars, whatever. So that's a brief of how the system has been built. Let's go through the code now. Let's kick things off with understanding the orchestrator. How do you build an orchestrator? The two endpoints that it supports. Number one, get/next problem, which every worker will ask from time to time. Can you give me the next problem, please? How do we write this endpoint? And the post results endpoint, where once the worker has solved a problem, they will post back the result. Okay, here is the result for this specific application number. Let's look at the orchestrator code. The final code you'll find in the description. Ignore the ops library for now. In the source folder, just focus on orchestrator and worker. The other two libraries, Bootstrap is just for bootstrapping the database. Ignore what that means, and database just exports the database. Orchestrator and worker are the two important folders here for you to look at. Let's kick things off with the orchestrator. Single line, single file here, nothing too complicated. An express server that does what? Exposes a /next endpoint, which the workers will hit from time to time. This worker will ask, hey, can you give me the next problem to solve, please? You will return them the next application number, which is db, which means database.application_number.find first. Give me the first application where pickup time is null. If it has been picked up by a different worker, don't give me that. Probably a different worker is solving it. If it has not been picked by a different worker, then give me this specific problem. If I don't get any problem, which means all the applications have been solved for. If I do though, we update the pickup time to be new date, which means make sure the database knows, okay, this has been picked up by a worker. Ideally, we should be storing a worker ID here, or something like this. to know if there's a worker who's just picking up values but not solving things like these. And then lastly, we return this back to the end user. If I currently hit neet-orchestrator.100xsteps.com/next, you will see it returns me an application number to solve. Now, of course, I hit it directly in the browser. It got me an application number. I am not solving it. So, you need to find a way to make sure a single worker is not hogging all the application numbers and not solving it. That's the first endpoint here. There are a few problems in this endpoint. Number one, two workers can get the same application number. If this request comes from two workers at the same time, unfortunately, they will get back, the same application number. So you should fix that. You can use locks in databases to fix that. You can just log the database here between these two transactions to make sure that, you can just update it here, I guess. Update pickup time to null, something like this. When you're fetching, you also update the thing. Yeah, this should probably work. Or just, creating a transaction also won't be enough. You will have to lock the database, basically. Doesn't matter if you don't understand it, it's fine. It's a little too much of a detail. Number two, a single worker could hog all your application numbers. They can just keep hitting this endpoint and say, okay, I've picked up this, not solve it. So how can you fix this? Is clear that you can add rate limiting on the worker side. Yes, you have to. Now you are fighting against the workers. Just how NEET NTA should be fighting against people like us who are trying to scrape. You need to not trust the workers. You need to make sure that whatever they do, they are not able to directly talk to my database. If they're giving me a result, I need to verify that result. And they're not calling the /next endpoint again and again and hogging all of my application numbers. Cool. Good things to fix. Fairly simple to fix. Not fixed over here. And lastly, a post endpoint /result, which when a user is able to solve a problem, they send you this result. They send you, care for this application number, this is the name of the candidate, this is their AIR, day, month, year, and the marks that they got. Now the next thing we do is we actually verify ourselves. Is that really true? We call send request, which is a function we have defined somewhere, which pretty much sends the same request again to neet.ntonline.in. We ourselves also ensure we're not sending it for every date now, but that one date that the user has sent, we don't trust the user. We still check, is that really the case? Is this a valid day number, year, application number combination? And if it is, then we're good to go. We can simply update the database or /add an entry to the results database. We should also do another update over here on the application number database, set solved to be true. Even if we've not done it, that's fine. But high level, the idea is to add an entry to the results table. You should also do basically this: await db.application_number.result, set solved to be true. If you look at this application number table, you'll see there's also a solved entry over here, which remains false right now. We should update it to true. This is the pickup time when the worker fixed it. This is whether or not it has been solved. That's a brief of the orchestrator service. Fairly simple. There's another endpoint that I just added for debugging purposes, /total. That just gives me all the users who have marks set. As I told you a while back, marks is something I added later on, which is why some entries are there that just have the ranks and not the marks. I just wanted to see how many of them have everything. This /total endpoint finds all the results which has something in the marks entry over here, which has marks set to something, 720, 719, so on and so forth. If you go to neet-orchestrator.100xsteps.com/total, it'll return you this count. 8695 entries have been solved. Harkirat, this is very different from the 11,000 entries we saw over here, because not all 11,000 entries have marks on it. As I said, some of them don't have marks set because initially I was not adding that logic. Here the logic says when you hit the /total endpoint, we will get all the entries where marks are not null. And that's exactly what happens here. And you get back these entries. As I said, if you look at it, there is one person who has marks 720 that we were able to scrape. This person right here, and basically tells us it's working as expected. If it keeps on running, right now we have 10,000 entries. If I run it for another few hours, it'll reach 50,000, 100,000, and then 25 lakhs. Alrighty. That's the orchestrator service. Hopefully we understand this fairly simple stuff. The worker is the thing that needs to poll the orchestrator, get the next problem to solve the problem, and then tell the orchestrator, there you go, I've solved the problem for you. This logic should be fairly simple. We just wrote it in the last section. If you open worker slash index.ts, you will see we call a main function which infinitely, it's basically running a loop and trying to solve a problem again and again. What is the problem? First hit the orchestrator server, get the next endpoint to call, then get the application number from there. If the application does exist, then find the rank of that specific user. What does the find rank function do? The find rank function firstly logs I'm finding rank for this application number. Then again, the thing that we had done. Now this is a more complicated way of doing the same thing. I create this args, which stands for arguments array. And then first I iterate over all the days, months, and years and push them to the arguments array. I don't do the month batch send logic that I did in the last section. I'll share why I did this. The reason I did this was because I wanted to make the batch size configurable. The number of requests that we're sending out together, I want to make this configurable. Okay, I want to try 25 also, I want to try 50 also, I want to try 100 at the same time also, because one of these might be an optimal number to send requests together. And hence, rather than writing the logic we wrote in the last section, I just push a bunch of things to this arguments array. Basically, all the possible dates, I push this arguments array, and then I send requests in batches with this batch size. I first send request for the, let's say, first 0 to 25 values in the first iteration. Batch will contain args.slice, which means give me the everything from 0 to 25. Give me the first 25 elements, and then I await promise.all on sending the request for that specific day, month, year, and application number. If it is solved, then what do we know? We can tell the orchestrator, okay, hey, the problem has been solved. Here is the application number, candidate name, so on and so forth. The send request function again is the function that actually sends the request to NEET given this day, month, year, and application number, and returns a true or a false, or solved as true in case this request, the request to the NEET server, if the Axios request does succeed, it returns candidate name, all India rank, solved, marks. Now this logic is written separately, like very differently to how we wrote it earlier. You can just use the same send request function from the last slides. You don't have to do this. This is a slightly more complicated version of the same thing, which is that we're returning a promise, which again, if you don't know what a promise is, then feel free to skip, use the other function that we wrote a while back. And just this function should just return these 4 values, or it should just return null or solved :false in case it did not find an entry for that specific day, month, year, and application number combination. And lastly, if as I said, if you do find something, then you set done to be true, and then you break out of this loop in case you're able to solve the problem. And then you just proceed on to find the next thing. That's how we're running an infinite loop on all the workers. If you look at it, I put a log over here and just tells us how much time did it take for a specific batch of requests to get handled. How much time does it take for the NEET servers? This request sends a request to the NEET server. I am sending batch underscore size number of requests together. If this batch size is 50, it means I'm sending 50 requests together. This specific log tells you, okay, the first 50 elements took, let's say, 2 seconds. The next 50 elements took 5 seconds for the request to get sent, so that you can constantly check, are the NEET servers down? Are they taking a long time, short time? If I start 20 processes on my machine, does the time go up or time go down? Things like these. If you want to look at a production worker that is currently running, let me quickly show you the logs from it. If you look at the logs from a production worker, other than all the errors that are coming here from time to time, it's telling batch 600 took 23 seconds, which means it took 23 seconds for 50 requests to go out, for which calculated the results for the 600th and the 650th argument over here. and then 650th to 700th took 56 seconds, this took 45 seconds, so on and so forth. This number has suddenly become really high, which tells me the NEET servers are currently acting up. Yeah, they're really slow. This number was very low yesterday. It was like 2 seconds, 3 seconds, something like that. Right now it's really high, probably because the NEET servers are down. I can also tell that based on this log that came. It's throwing errors from time to time. Doesn't matter really. If the NEET servers are slow, they're slow. There's nothing you can do about it. But yeah, that's a brief of the worker. To recap, what does the worker do? The worker first talks to the orchestrator. It asks the orchestrator, hey, do you have a problem for me to solve? Orchestrator URL /next. This returns an application number for it to solve. And then it just calls the find rank function, which sends requests in batches to, if this is the NEET server, it sends requests in batches to the NEET server. It will first send 50 requests and asks, hey, are these first 50 date of births right? And after this succeeds, then it will send the next 50. And whenever it does find a date of birth that works, it will let the orchestrator know, okay, hey, I've solved the problem. This is the specific date, 0102, 2007, let's say, for this specific application number. So that's how you solve this problem in a deepened network, decentralized physical infrastructure network. Harkirat has physical infrastructure at his home. He has a Mac machine on his home. This is my Mac machine. I can run the worker locally as well. I can run npm run start : worker, and this would start a worker on my machine. If you want to run it on your side, it's containerized, so you can run a simple Docker command and that will solve it for your side. For example, here it says finding rank for this number. Request reach here. I got back an application number. I'm trying to solve for that application number by calling this find rank function. This got logged on the screen. And now the first batch of 50 requests have gone to the NTA server. Now my Mac machine is talking to the NEET server. But since I'm running a bunch of workers, as you saw a while back, I was also running a bunch of pods or, let's say machines somewhere. All of them are also currently talking to the NEET server. So there's a good chance, these 10 machines that I have running are causing the NEET server to be slow. We can confirm by, scaling this down and then seeing the time it takes. Most probably it's not me. Because yesterday I had like 50 machines running and it was working fine. So I don't think it's me causing it to be slow. I think it's just being slow. Either way, I'll just have to keep this running for really long time. In around 5 hours, I was able to get 9,000 entries. So if I run some simple maths, okay, 5 hours on 50 machines, let's say average probably was 30 machines, gave me, let's say 10,000 entries. And then, I can just scale this up. Okay, how long will it take for me to reach 1 lakh entries? I will take 5 hours on 300 machines to reach 1 lakh entries. How much time will it take for me to solve for 10 lakh entries? That will be 50 hours on 300 machines, and total number of people in NEET are 25 lakhs. So that just means into 2.5, that's 125 hours. So if I have 300 machines on which I run this for what is that, 5-6 days, then I'm sorted. How much does it cost to run 300 machines for 6 days? Probably not a lot. I think each machine doesn't need to be more than, if I'm being honest, $5, but let's say realistically $10. So $10 a month, that's 10 into 6 divided by 30. This is the amount we have to pay for them for 6 days into 300 machines. So I have to pretty much pay this much, which is $600. That's actually not too bad to solve this problem. I was expecting close to $1,000 to solve this problem. And again, if a lot of people do it, then I can just do it in $500. I can just pay them a little bit lesser. But yeah, that's a brief. I think if you have infinite time, then you can just keep scaling up time. You only need one machine. If it on 30 machines it takes 5 hours, on one machine it will take whatever 5 into 30 hours, and then for these many values I need just these many hours on one machine. But that's too many hours. That's like years it will take. So I can do it only on my machine. I shouldn't though. I should just distribute this out to a lot of people. And if I have 300 of these machines running somewhere, then in 6 days I'll be able to scrape all the results. This gets better if you're closer to the NEET server. If I can figure out what data center they're probably using, a cloud provider. So if I get closer to their cloud providers, if I start something in the same data center, then of course this request time goes down, and hence any optimization that you make here, if I write it in Rust and let's say that speeds up the process by twice, it won't by that much, but let's say even if it speeds it up by 20%, then I can save 20% on my $600 bill, which is like $100. You get the idea. All right, is there anything else? I think the only other thing is I did containerize this. So, if you do want to run this locally, you can run docker run 100x devs / neat, and that should just run it for you. You don't have to do anything else. You just need Docker installed on your machine. And similarly, you can create a Kubernetes cluster like I have right now and create a deployment over there. You can just scale up the replicas based on how like whatever you can afford at the moment. If you can afford 20 machines, then maybe put up 50 replicas. That's what I did yesterday. Right now also, I think I'll let it run all night, even though it's taking a really long time right now, so it won't be super effective, but still I will probably let 20 machines run 50 replicas all night today. Let me just show how that happens in case you're curious. I'm currently running my Kubernetes cluster in Vultr. You can run it in AWS, doesn't really matter. And in case you do use a Kubernetes cluster, all you have to do is scale up these replicas. Right now the number is 10, which is why if I do kubectl get pods, it shows me 10 pods over here. But if I scale up the number of machines, if I go to my Kubernetes cluster and add like a bunch of nodes, I currently have like only 2 nodes running, which is like 2 machines. But if I bring this up to 10 machines, let's say, okay, I want to start 10 machines, and then on each machine, let me start 3 pods or like 3 Docker containers or 3 processes. So wait for this to happen. It's been resized. It'll scale up in a few minutes. If I go back to compute, you will see I will see 8 new machines that are starting. And then if I go here and increase the number of replicas to 30, then by running this command kubectl apply this specific deployment, then it says this deployment has been configured, which means I've just started 30 processes now. These 30 processes will eventually run on 10 machines that I just started, or more specifically like 9 machines over here. Doesn't matter either way. One of them is a master, and nothing runs there, but the other 9 will have 30 replicas running on average around 3 processes a machine. And I can just look at the logs over here and figure out what's up. For example, if I look at the logs for this one, it just started finding the rank for this. Now the NEET servers are shitting bricks from what I can tell, which is why I don't see any other logs. Yeah, as you can see, now this returned me an error. Internal server error, the above error request, the web server processing a request. I don't know if this is me, most probably not, but we can confirm. We can scale down our number of replicas to 0. And if that brings up the NEET servers, that means this is us. Most probably this isn't us. Pretty sure they can handle 30 machines into 25 requests. That's not a lot of requests, like 600 requests together. So I don't think this is us. I think their server is just slow at the moment. Let's try this out with I'm pretty sure their server is slow. And I don't think it's because of us. That's all I had for this video, guys. Once this compiles, the only thing that's left is creating a website similar to JEE.100x, sorry, whatever, sjslabs.co, something like this. If you want to pick this up, feel free to create a front end similar to this, which gets entries from this results table, sorts them up, and shows them to the user in a paginated fashion. That'd be a good thing for you to add. I'm assuming it's straightforward to create that website, and based on this database, you can just query the database whenever a user comes to neet.100xdevs.com, let's say. They're just able to see the NEET results for this year. The database is slowly being seeded. At some point it should have all 25 lakh users, depending on how much money we're willing to spend, how much compute we're willing to get. But yeah, when that happens, this number will keep going up and eventually reach 25 lakh. That's how the results of everyone. That's all I had for this one, guys. Let me know if this video was insightful or not. I'll see you in the next one. Bye bye. Alrighty.